So the question that we are going to look at today is flip string to monotone increasing. A string is a monotone increasing, as you can see in the examples, if either it should have all the zeros in it, or it should have just ones in it. But basically towards the end, if it does have one, the ones should all come towards the end, and there shouldn't be any zero in between. So if you look at this 1 0 at the end, so this is not a valid monotone. You have to flip this 0 to a 1 for it to become a valid monotone. We need to return the minimum number of flips that are required to convert a string into a valid monotone increasing. So basically the thought or the idea behind it is that somehow we need to keep a track of how many ones are present in our string. And at every index, if we can somehow convert all the ones that lie to its left into zeros, and all the zeros that lie to its right to a 1, then it will become a increasing monotone, right? A valid monotone. So if we have, let's say, 0 0 1, and then we have 0 and 1 1 1, if we are at this index, then just flipping this 1 to a 0 will make this a valid monotone. So basically at every index we have to keep a track of how many ones are present on its left, and if there are some ones present on its left, we want to convert them to zeros. And if there are some zeros present to the right of that index, we want to convert them to ones. And then we will keep a track of how many operations are required to do that at every index. And then out of all those operations at every index, we'll pick out the minimum value, because we want to give out the minimum value, minimum flips required. So the way that we can do that is, let's say we can create an array which is one length longer than the length of the string, and we'll see why. This array basically will just keep a track of at every index how many ones came to the left of that index. Okay, so if we start from 0, then there's no 1 to its left, so the value is going to be 0. At index 1, we can see there's 1 to its left, so the value becomes 1. At every index, if we are keeping a track, then for 2 on its left, it is still 1. For 3 on its left, it's still 1, because we are at 3 and we're considering only the values on its left. So it's still 1. And now here it becomes 2, right? Because at index 4, there's 2 2s on its left. Now it becomes 3. It stays 3 here, it becomes 4 here. And we need this array to be one length longer, because for the number of ones that come to the left of index 7 is going to correspond to this value. So this is 4. So if this is a string of length 8, then the array that will keep a track of how many ones are coming to the left of that index in this string is going to be of length 9. Okay, so now how does this help us? At every index, we're going to find out how many operations are required to flip the zeros that are coming to its left, right? So if we go to, let's start from, we're going to do this for every index, but in this example I'm going to show just a couple of indexes. So if we go to index 2, right, this is the index 2, we see the number of ones that are present on its left is 1, which is this one. So for it to become a valid monotone, at increasing monotone at this index 2, only this 1 has to be flipped to a 0, which will require just one operation. So we have this 1. And now we look at the the right, which is going to include this index, because we did not include this index while considering the ones that came to its left, right? So from this index included, there's 3 zeros that need to be converted. There's 3 zeros in this string that need to be converted. So there's going to be 3 operations to do that, which will turn out to be 4 operations. If we go to index 3, this is the index that gives us the right answer. So if you're at index 3, the number of ones on its left is just 1. So to flip that, just one operation is required. Including this index 3 till the end, we've got 2 zeros. So to flip those 2 zeros, you only require 2 operations. So you have 3 operations. And if you look at this, the correct answer to convert this string is you convert this 1 into a 0 and these 2 ones, these 2 zeros into a 1, right? Now, with all that done, how do we keep a track of how many zeros are present on the right of every index? So we do have the length, and we do have the total number of 4s that we encountered after traversing the entire string, and we have the count of how many ones are present on the left of that index. So if there's only one present on the left of the index and there's 4 ones present, that means that 4 minus 1, the other ones are lying on the right? Now the length of this from 3 to 7 is 5, which is basically the length of the string minus the index. This gives you the length. So if the length of this substring is 5 and 4 minus 3 are the ones in this length, then the rest are going to be 0, right? So this gives out the value of the zeros, which is 5 minus 8 minus 3, 5 minus 3, 2. So let's look at it again. The length is 8. We have the number of 4s, total number of 4s present, total number of 1s present, which is 4, and we subtract 1 from it, which is the one that is present on the left. There's only 3 ones that are present on the right, and if we subtract the values of those ones from the length of the substring that we're considering, we get the number of zeros. So now after this, it is pretty much straightforward. You just calculate the number of operations required at every index and you keep a track of the minimum and you just return the minimum. So let's start coding. First we need to create an index to keep the count, right? Count of ones. This array. So we need an array to keep a track of number of ones that we see on the left of every index in the string. So it is going to be a new int array, and as I said, it is going to be one index longer than the length of the string. Let's also keep the length because we're going to need it. The length is this number, the length of the string. So just length of the string. I don't want to keep using the function everywhere. And for this, the first index is always going to be 0 because there's nothing on its left. So we can just set it to 0. And let's keep a count of ones that we are seeing. We will need it, this final count. We can read it from the array. I'm just keeping it here. Now we have to start looping from index 1, right? Because we've already set the value for index 0 smaller than equal to the length of count the length minus 1 and I plus plus if the character is equal to 1. If it is equal to 1, but we are going to have to look at the index I minus 1 because we are starting from 1. We want to start from index 0, right? So if it is equal to 1, then not ones of count, just ones count. Then ones count should be incremented by 1, right? And you just want to set the value for this here equal to ones count. if the character that we read is 0, then we did not update the ones count anyway, so we can just use it. Now we need the result. We're going to set it to the maximum value because we're going to pick out the minimum, right? So integer dot max value. And now let's loop through. Smaller than and equal to count of ones. Just take this. And J++. Now we're going to use 1 to left. It's just going to be the value that we read from that index, right? Ones on the left is represented in here. So it's just the value from the array itself. And zeros to right. This is going to be length minus the index. Length minus the index minus total number of ones that we saw, which is ones count. Ones count minus how many ones were present on the left. So total number of ones minus ones on the left gives us the number of ones on the right. Then we subtract it from the length of the substring and we get the number of zeros on the right. And the result is just going to be the minimum of result itself and addition of these two values to flip the ones on the left to 0 and to flip the zeros on the right to 1. Then we just return the result. Right? I think this looks good. If we try out with the example that we had, it should give us 3, right? So the time complexity of this is going to be O of n because we are looping through the array and you're looping through it twice, so n plus n, but 2 would become the constant, so basically just n. And you are storing the count in an array which is just one index longer, so the space complexity is going to be O of n as well.